So I think most of you know how to play a design game. Who doesn't know how to play a design game? All right, so I will go over this. It's very simple, like playing Monopoly, playing a card game. What are some of the commonalities when it comes to playing card games? I know you guys know the answers. You have to take turns, right? You can't just have one Monopoly that's trying to take over the whole thing. And we want to make sure that everybody's got enough time to say what they need to say. So there's equal participation. So we want you guys to take turns. And then when it's your turn, you can choose a design game card, and we have different videos and precedents up on the portal. If you haven't registered for the portal, we can give you the URL. You can sign up for an account. So you can go in there. If you don't know what to propose, you can go on there and just find something to use to propose. Or you can design your own idea. You can draw whatever you think is the most optimal space room system, and then use that and propose that as an idea. So you need to have an idea, a best practice prototype, and then you need to also tell everybody where it's going to go. You know, is it going to be everywhere, or is it going to be in one part of the space habitat and so on? And then you guys would take turns putting down these ideas and finding locations for these ideas, or taking away someone else's ideas if you think that previous idea is not going to work. But we don't want people to get into fist fights, so we need to have some sort of rules of engagement, because we don't want one person to be the one calling all the shots and others don't get to have any interactions or say on anything. So we want you to argue politely in terms of the strengths, weaknesses, opportunities, and threats of what you're proposing. So how is what you're proposing transforming the weaknesses and the threats into strengths and opportunities? So strengths and weaknesses are a pair of good or bad conditions in terms of what's present. But opportunities and threats, they are a pair of what's good and bad in terms of what's yet to come. So if you can argue in terms of what's currently not so good, what might be potentially an issue, and how what you're proposing is able to convert what's not good right now, or what could be an issue in the future, into what's good and what could be a promising solution in the future. Does that make sense? So if you can argue in terms of that, you can take away someone else's card, right? And say, hey, that doesn't really quite make any sense because it's not addressing these weaknesses or threats, right? And then so this is an example of how you have a piece of tracing paper, and we have a roll of tracing paper there. You're going to put down your ideas, and you're going to find locations for those ideas or draw where they're going to go. And people are just going to continue to put ideas down. They're going to take turns, and then we'll take away someone else's ideas until everybody agrees with what's being put down. So another example. So once you all agree with what's being put down, you're going to present your idea. You're going to try to color code, maybe color code, or try to connect your ideas, you know, with where it's going to go. And you're welcome to download some images from World Wide Web and just put those images into your PowerPoint presentation, right? You can find any precedents or any best practices that are appropriate for your game cards. So we pre-made some cards here. There are more on the portal, but these are just different ways of integrating microbial fuel cells into the landscape. So you can see how we have the green microbial fuel cells that are completely plant-based. It doesn't have any water components. So what's different is that the anode is deep, deep, deep inside. The cathode is closer to the surface where there's more oxygen. Oh, I think this is wrong. So anode should be down further at the bottom. Yeah, this is reverse water. So CO2 should be down here and O2 should be up here. So this is wrong, should be fixed. And then you can have the blue system where you got the wastewater here and you have the clean water as a byproduct of the cathode. And then you also have the blue-green system, where you might have where the plant root zone is. You got a lot of biofilm and microbial activities, right? More of an anaerobic condition. And then you have another zone where you grow some plants hydroponically, so you can continue to keep that water clean for the plants as well. So we will encourage you to be creative, to think about how you can use microbial fuel cell in a multi-scalar way, right? So we can even zoom out from here. How do you think about microbial fuel cell at the city level for the entire biome? Where you might think about, different ponds located in different parts of the biome. Maybe you create artificial terrain where some ponds are located higher than other ponds located lower. And you might have places where you got the rotational paddocks and the manure water is going to come down, where you're going to get more organic content for your anode. And then you might set up an anode here and a cathode here, or you might set up anode and cathode with anode lower, cathode higher. So you can think about the relative horizontal and vertical relationships of different landscape components in terms of whether you get enough organic content input to make it an anode, or whether you're going to have enough plants to convert the CO2 into oxygen to have your clean water as your byproducts. So another possible solution or design out of different ways of using this concept is to rotate this prototype 360 degrees. So I would encourage you guys to think about different concepts as a multi-scalar exercise. Does that make sense? So you start with a very small technology aspect of something that's considered best practice, and you think about how it gets applied at the prototype level, at the biome level like this, and so on. So we have a very small team because we have people being trained right now for their important missions and people at NASA. Maybe we will see who is not an engineer here versus who's an engineer. Okay, 1, 2, 3, 4, 5. 5 non-engineer. 6. So life science. Can we have life science? I know Ro has your life science, College of Medicine 2 life science people. Are you an aerospace engineer? All right, aerospace. Okay, so another engineer. How many engineers? Raise your hand. 1, 2, 3, 4, 5. Okay, so we will do this. We will have 5 teams, 5 engineers. Each engineer will lead 1 team, and 5 non-engineers will join them. And then we will have 2 life science people join whichever 2 you prefer to join. Okay, make sense? All right, so we will have 2 to 3 people per team, and then we'll have 5 presentations. Okay.